Trinity Maths, Coordinates and Straight Line Graphs. This is our destination. How do we get there? Close the Excel file. From Trinity Maths, select Graphs, Open, Coordinates and Straight Line Graphs. This is a macros enabled Excel spreadsheet, and I'm looking for find the equation and point of intersection of two straight line graphs. This is an interactive graph showing two equations of a straight line in the form y equals mx plus c. Let's hide the green line and focus on the blue. Before this activity, our pupils will have plotted straight line graphs and understand the terms gradient m and y-intercept c. The gradient triangle is a useful feature here. Adding it shows that each time x goes up by 1, y increases by 2, so m equals 2. It cuts the y-axis at 1, so c equals 1, which gives y equals 2x plus 1. I have dynamic control of m, which has 46 different positive and negative integer or fractional values, including reciprocal pairs. I have dynamic control of C, which has 11 different positive and negative integer values. Let's return to the starting condition, y equals 2x plus 1, and bring back the green line. Its gradient triangle shows that each time x goes up by 1, y increases by 4, so m equals 4. It cuts the y-axis at minus 3, so c equals minus 3, which gives y equals 4x minus 3. We can identify the point of intersection here as 2, 5, which is easy to find since this is a lattice point where two grid lines meet. Now this is all very procedural, developing our pupils' fluency, but how can I introduce an element of reasoning or problem solving into this activity? Let's reset the screen, but reveal each equation and hide both lines. Now change the blue line to y equals minus 3x plus 5. And make the green line y equals 3/5 x minus 4. After giving them printed xy coordinate axes, which you can download from the Trinity Maths website, ask your pupils, can you find the point of intersection by graphical methods? The blue line's m equals minus 3 and c equals 5. Because m equals minus 3, each time x goes up by 1, y decreases by 3. Now we have its gradient triangle extend the blue line. The green line's m equals 3/5 and c equals minus 4. We know gradient m equals change in y over change in x. So because m equals 3/5, each time x goes up by 5, y increases by 3. Now we have its gradient triangle extend the green line. The point of intersection is 2.5, minus 2.5. It's given as a mixed number, not a decimal, because in some circumstances, such as when m equals 2/3 or m equals 1/2, both x and y will be recurring decimals. Finally, we might ask our pupils to find the point of intersection by algebraic methods. They can do this by equating the two lines, then solve the equation minus 3x plus 5 equals 3/5 x minus 4.